and it was full. We're charging $40. So this is a bargain for Matt's class. His lunch money, his carpet bomb, that's just a few of the many flies that are sold in fly shops across the country. So this is a great opportunity for us, and you don't need to be an expert tyer to take this class. If you can tie a woolly booger, as Matt says, you can tie his flies. Doesn't want to make a beginner's class where he's teaching people how to do thread and knots and all that. But I would say that just about everybody who's been to our fly tying sessions is qualified to take his class and be in there. So I expect we'll probably fill out easily. And there'll be a waiting list. And what we'll do is the people who are on the waiting list will get to attend as watchers. We won't charge you $40, we'll charge you $10. But if a seat becomes available, last minute cancellation, we'll go in the order of the waiting list and that person can take that seat. So we won't have empty seats, and we'll give everybody an opportunity to actually do hands-on tying with Matt. It's going to be at the Bulow Randolph Historic Site in Pineville. It's going to be from 9:30 until 1 o'clock. And we should be able to do 4 patterns. We definitely will do 3, but we should be able to do 4. And so Matt's agreed to do 4 patterns for us if time allots. The park doesn't open till 9 o'clock, so there's no use to get there early. It gives 30 minutes to set up and everything else. And that's August 16th. And we do have a fly tying session before then, right, Bill?
Yeah, it's meeting Tulips Wigglebug.
And that's August the 11th? Okay.
What was the name of it again? Tulips Wigglebug. It's Darren Green when he presented on fishing the creeks in Kisatchie in southwest Louisiana. He said it was one of his favorite spotted bass patterns. It's like a Rapala, basically, that's curved a while. Yeah, he dives under the water. Wiggles. Really cool looking match.
So Bill will send out notes on that. We'll have it on the website as well, on social media, on our Facebook page and Instagram. And then for the 25th of next month, we have Susan Brooks, who's the director of Casting for Recovery in the Southeast region. And she's going to come talk to our club about what they're doing, what she's doing for casting recovery in this area, this region of the country. And so since we raised over $1,000 for her efforts, and as well as New Orleans fly fishers and red stick fly fishers and Gulf Coast Council, this should be a great meeting for us to hear all the great things that they do. And we've never heard Susan's presentations before. It's quite moving. So we're going to, that'll be August. And then September, we'll have our regular fly tying meeting. But National Hunting Fishing Day is on the 27th. And so we've always been part of Cenla National Hunting Fishing Day in Woodworth. I have to fill out the form sometime in the next 3 weeks. So I'll send out an email to club members to see who wants to be an official volunteer. And the difference between an official volunteer and an unofficial volunteer is the official volunteer gets a T-shirt and they get their names in a drawing for prizes that they draw at the end of the day. So if you want to be an official volunteer, but anybody who's interested can come and tie flies to help us teach casting, show casting to kids and all that. Then in November, we have Sugar Day on November 8th. It's been confirmed. So we'll be doing fly tying over there at Kent Plantation House, as we've done in the past. And that's usually a great event. We get a lot of people come by for that. I don't have any trips on here yet for the fall. I'm sure we'll be working on that.
Going to September, Architects, Oklahoma, Texas, what is it? They're doing the thing in Natchez again on the 24th.
That's right. Thank you for reminding me.
And Bill and I found out last year, after we got there, we left, that they were wanting donations for flies. What did they donate? Do you know?
Wounded warriors, maybe?
So, yeah, they were wanting us to tie flies to donate. We wasn't aware of that when we got here.
It wasn't casting for recovery. It was,
No, it was something, I think it was on that healing water.
yeah, maybe one of those, yeah.
Yeah, so that's a conjunction I see with the Meat Pie Festival.
Yeah.
So they'll be at the First Baptist Church of Natchez Gymnasium.
Oh, they moved. We
Yeah.
didn't down that.
Yeah. So, yeah, they'll be in conjunction with that event. And they'll be there from 9 a.m. to 4 p.m.
Point.
Mm-hmm. It's free admission. Anybody wants to go to the fly tying event.
Well, they just let everybody tie, just walk in and stuff, sit down, feel time.
Yeah.
A big powwow, just.
Yeah.
Burley was there and
Yeah, there wasn't much public involved.
it was just all of us together, just a big, everybody talking at the time.
Well, they are publicizing it on social media, I see. So hopefully people will come by and watch it and see it here. Anything else I'm missing? Okay, any fishing reports? Yeah. That's pretty much how it is right now.
Caught some gar last week.
Good.
Guards catch.
Short note. Oh, he spotted. Yeah, I failed on the gizzard shad. So.
Oh.
We had a,
I caught like 8.
I'm proud for it.
Yeah, that's how they work. Yeah, sorry, Gantz and I went to a presentation at Acadian Outlaw Runners about gar.
Ken Holmes, yeah.
Yeah, and man, that was fantastic. He was almost a gar psychologist. This was gar whisperer. The gar whisperer. Oh, yeah.
yeah, he is.
Very important. Did he talk about his golden gar tournament?
Yeah.
I'm in that tournament.
So are you really?
Yes.
What is the golden gar tournament?
He invites 13 people. It's kind of a tongue-in-cheek kind of tournament, and you have to fish on Old River near Bachelor, Louisiana. And each of the 4 species of gar are in there.
Oh, wow.
And each one, it represents a face card in a deck of cards. And in a day, you build a hand. So you need to catch 5 or at least 4 to be competitive. And you build a hand, and at the end of it lasted 2 months. At the end of that, everybody comes around with their hands, lays them on the table, and whoever wins gets a belt buckle passed around. And it doesn't cost anything to enter it. You just have to write a haiku about garfish.
They showed this film at the end of the Fly Fishing Film Festival in Gulf Shores in front of 200 people.
Yeah.
And it got the most applause. I think it got standing ovation. So it really is a really good video. I mean, and you can see it on YouTube. He's got it on YouTube now. So it really is a good film, good production. Yeah, we're talking about the golden gar. Fishing report on that is after we had seen that film at Acadiana, I came back and I was standing on my dock and I saw gar rolling like that. So I went back and got a game changer and came out there and I almost hooked one. And I mean, that thing came up and just went like that. And somehow he did not get the hook in his mouth. So I see the challenge of catching these things. Well, I had a bite tip it on, you know.
And they're coming up for air and not always eating, so it's frustrating to see them rolling on top of the water and not getting there.
I think he was after my fly. At least that's my story and I'm sticking to it.
It's flies, is that what it is?
No, we used to use the road flies.
Okay.
And articulated, I caught 5 last week, week before last, the diversion now. and clouders, but then the best hookup I had was with an articulated.
So you have the second hook.
And you got both hooks.
Oh, wow. So that's,
Yeah.
Are you sure that they don't go over high up or?
They were rolling on top, so I tried everything. It's deep, shallow. You know, just, and you get eats occasionally and they just don't hook up. You know?
When they hit, they turn loose because they re-grab that thing. And that's what you gotta pause and wait on, because if you don't wait, come back with it.
Yeah.
Is it appropriate to still leader?
Do what?
No, no. Oh, yeah.
I
Oh,
got
yeah.
stuff I'll show you. You don't need a steer, I got tippet.
No.
I use 16-pound fluorocarbon and I haven't made one. Yeah, but they could.
Well, I know when I was saltwater fishing down in Charles, I mean, I have two. One of my casts I saw, I did guard, so I cast to it. And it wasn't a big, he was pretty sexy. So I had the other one run for the water. I had, I think another one cast into shore and it took it, whatever it was, it just started going out. I couldn't even turn its head. And I was using my 8 weight with, I think, 12 or 15
That would
pounds.
have been a big alligator going.
Yeah, I don't know,
Yeah.
practice water. I never saw it, but it just went past me and kept going.
That's what they do. That sounds like an alligator gar.
But I didn't feel any whip.
Yeah. Just the alligator, not the gar.
You don't have to wiggly, it's just a slow.
That's what it is. That's why I figured just to run with a big gar, but I couldn't budge.
Well, if what you want to go after is big fish close in, this is the time to do it. August and September down Grand Isle on the coast. I've caught inside Caminade Pass. I've caught king mackerel, Jack Crevalle, Spanish mackerel. You know,
What size of bottle?
hey, wait.
You're outgunned.
With the king, I was. It was like. I could see him jumping over there. My line was going like this. But yeah, you can. The Spanish are fun to catch. They will attack.
Boat or kayak?
Yeah, the kayak. Oh yeah, it was something. I mean, they just crashed that.
Let me know.
Just a regular gray white trouser, and I'm just throwing it out there. You see them busting the menhaden, and you just throw it out there and strip it as fast as you can like this. And when they hit it, you hear that, and it's like, and they just fight like crazy. And they're good eating too if you bleed them. As soon as you catch them, just bleed them, put them in the ice chest. This is nice white meat, pan fried and grill it. It's good eating, but they are fun to catch. They're inside right now. Bluefish, you'll find some bluefish inside as well. But the Jack Crevalle, make sure you're fishing a light tippet. Because after about 30 minutes, you're going to want to do this.
I see some pictures where they are down.
Yeah, they'll just tow you around. Yeah. I was fishing with a buddy at North Shore Lake Pontchartrain, and it pulled him about 2 miles out. Because he had a heavy tip and he was going to land that sucker. Didn't happen. Did not happen.
You're throwing the old man with the whale, you know?
That's right.
Ron Roberts broke his 8 weight on Jack down in Alabama at Gulf Shores.
Oh, he did?
Classic. He was live streaming himself, towing him around and broke it right above the grip.
Yeah. They are just, yeah.
Right?
Yeah. They're fun to catch, but not fun to fight. Okay, last but not before we introduce our speaker, I have a couple of Fly Fisher magazines right here. Who's not an FFI member? In here. You?
I'm not.
I gave you one. You want one? Yeah, okay. Okay. In here. Give that to anybody else who's out there. Okay, those are club magazines we get from FFI. Since we're an FFI affiliated club. Okay, our speaker for tonight is Dr. Scott Raborn.
And Dr. Jones.
And, okay, team up, yes. Y'all with the LGL group. And earlier this month, y'all gave a presentation. Well, they gave a presentation to Louisiana Wildlife Fisheries Commission on their results of a study on the bycatch of menhaden bycatch, which has been a hot topic. If you've seen magazine articles, I heard same thing on social media. There was a big outcry about the number of redfish, bull redfish, the spawners, that were killed by pogie boats. And it led to some changes in regulations where boats now have to be 3/4 of a mile offshore, rather than previously they were up on the beach. So now they have to be further up offshore. But even so, there's still some concern that the menhaden boats are killing too many redfish. So I'll let Scott and.
I'll start over there like this.
Okay.
Yeah, just click on the pocket. Yeah, this study was a large collaborative effort from our group, and by the same token, it's a collaborative presentation. It would be awesome if I could see. Perfect. Thanks. Ideal. And then, do you think you could present a mode? Oh, awesome. Cool. That's all right. I'm also happy to just exchange fishing stories for like 30, 45 minutes, because that was also pretty fun. So cool. Okay. I'll just let you know when to move on to the next slide, so you can just go for it. Next slide. We'll get started here. So just raise your hand really quickly if you did listen to our presentation last month. Perfect. Okay. So there's only one person. There's going to be spoilers for one person, but the rest of you, this is going to be new information, which is great. Okay. So this is a quick overview. I'm going to give an introduction on LGL, what we are as a company, what we do, our research, our involvement in different fisheries in the Gulf. And then I'm going to cover the study in detail, give you a little bit of background, show you some pictures, tell you about what we found and potentially some of the next steps and future directions. So next slide. And next slide again. Perfect. Okay, so LGL Ecological Research Associates, that's our group. It's a much larger company. It was founded in Canada in 1971, and we're an employee-owned environmental consulting firm. And our U.S. corporations are based out of Texas, formerly Alaska, Washington State, and then Scott is based here locally in Pineville, Louisiana. So he has a satellite office, a home office here locally. Next slide. So our Texas office is really focused on kind of applied fisheries research, marine science. We do a lot of work in the Gulf. We do lots of work in Alaska and all over North America. Now, our projects and our research span marine environments all the way to freshwater environments and everything in between. So pretty broadly skilled set of scientists. We have folks that are experts in marine mammals, sea turtles, all different fish species, as well as invertebrates. And many of us are avid anglers. And so myself, I grew up fly fishing in England, for brown trout, sea trout, Atlantic salmon, lived in North Carolina for 6 years, fishing the Appalachians, and now I'm in Texas, and I try to fly fish when I can, go down to the Guadalupe River every now and then, and which is kind of a unique fishery if you guys aren't familiar with that. Anyhow, so we service a range of clients from private sector to industry to First Nations, and really one of our we're strong proponents of cooperative research. So where we can, we like to work closely with fishermen, both recreational and commercial fishermen, because as you guys know, right, fishermen are some of the best advocates of conservation. You guys also are out on the water probably more than anybody else. And so oftentimes fishermen are tapped in, they see what's going on in the environment, they see changes in populations of fish and habitat. And it's great intel for us is to bring in that scientific expertise and kind of collaborate on projects when we can. And so today's project is wasn't so much cooperative in terms of that the funding really came from Louisiana state legislator. And so in 2022, they appropriated $1 million in funding to essentially assess bycatch in the menhaden purseine fishery. So LGL, we were awarded that contract, and we did work very closely with commercial fishery to essentially design a study that allowed us to produce robust estimates of bycatch. And I'll talk about that more shortly. So next slide. And next slide again. So here's a little bit of information on the fishery. It started in the late 1800s. It's the largest commercial fishery in the Gulf, the second largest in the US in terms of just the volume, the landings of fish that they bring back to shore. Landings were about 1 million metric tons in the 1980s. At that point, the fishery had about 100 different vessels that were operating. Today, landings are around 500,000 metric tons, and that's what is kind of average for most of the last decade. Now, as you know, majority of the landings occur in Louisiana state waters. Louisiana is important habitat for the fishery. There's lots of menhaden. It operates and very heavily in state waters or adjacent federal waters in Louisiana, whereby 93.5% of fishing effort occurred in Louisiana state waters or adjacent federal waters in 2024. Next slide. Yeah, please.
Question. On that chart right there.
Yes.
Back when it was almost over 1 million, were there other Gulf states in which name?
Correct. Yeah. So the fishery used to operate on a much larger scale in parts of Florida and Texas. And so there's been multiple factors, you're right, that have kind of led to that decline.
Louisiana's the only one, for all practice purposes, the only one that left the Gulf states that still has any.
Mississippi still allows fishing. Our study was specific to Louisiana because of the funding avenue. And there's also some landings in Texas too, but compared to Louisiana, they're relatively small in comparison. Yeah.
What's being done with the menhaden? Like, what is that use?
Awesome question. Yeah. So they're like basically taking it back to these processing plants onshore, and they're grinding it up and they're making two products. They extract the omega fish oil that gets used in cosmetics, health products, you name it, the broad suite of different kinds. Yep. And then like the meat itself gets produced, basically a fish meal powder that they use in aquaculture to feed salmon farms and things like that. So those are the two main products. It's actually surprising, like since starting the study, I'll actively read the ingredients on just general things that you come across in Walmart, dog food, cat food. And oftentimes if you see omega protein or one of the other companies, that's basically a product from that fishery. So it's in a really broad suite of different products. So it's everywhere. Yeah. Yeah. So bycatch was, the focus of our study. What do we know about bycatch in the industry? Well, there have been bycatch studies roughly once every 10 years. Other fisheries have maybe kind of annual mandated observer programs. This fishery had been monitored once every 10 years with different studies, depending on funding. Now, despite that, there was some ambiguity over the extent of bycatch in the fishery. And the reason for that was, twofold. One of the problems was that when you have data that's collected every 10 years, doesn't build a really high resolution picture of what's going on. And the other side of it was it's a complicated, fast-paced fishery, and it's a difficult fishery to really accurately quantify bycatch. And so some of the previous studies had some limitations, and we learned a lot from them, and I'll talk about that shortly. But the two primary limitations were that there were some studies that were just conducted at the processing plants on land. And so they were only able to assess bycatch that was brought back to shore. The fishery releases a lot of bycatch in the ocean. So it was a whole component that wasn't captured, right? The other side of it was that studies that were conducted out in the ocean at sea on board the boats with observers, because the fishery is operating at such a fast pace, they weren't able to always characterize and view every single bycatch component that was occurring. You have 3 or 4 different things happening simultaneously in terms of like how bycatch is released. I'll talk about that in a little bit more with some pictures to kind of show you what I mean by that. But it made it very difficult to get a complete characterization of what was going on.
So if they're doing these studies at plants,
Yes.
fish are dead, right?
Correct. Yes. So anything brought back in the hold is a mortality. And so you know the fate of those individuals. That's a great question because it leads on really to my next point. And that is that the other thing that wasn't really studied previously was what is the fate, what is the survival of fish that are released at sea, right? So if you released X number of red drum, how many do we expect survive? And that was a second really key objective of our study. So to orient you around the fishery, for those that aren't familiar, there are three types of boats that they use. You have your fishing boats, right? That's these larger vessels up here. Fishing boats take the crew and the fishing gear out to the fishing grounds. They bring the catch back to the plants on shore so they can process it. You then have purse boats. These are these two smaller boats. The fishing boats have like basically ramps on the stern. And that's what deploys these two boats. Those are the boats that set the net around the school of menhaden. So that's purse boats. And it's kind of an interesting and unique fishery in that they have spotter planes. So those of you that have been off the shore might have seen these, but there's planes that are flying at pretty low level that are looking for schools of menhaden. And then they're, communicating with the fishermen in the purse boats below, directing them to the catch. And then the final type of vessel is what's called a run boat or a tender. You can think of that as just, it's like a special kind of fishing boat. So it's a fishing boat that doesn't have purse boats. So what it does is it goes around and it extracts the catch out of the nets from the other fishing boats. And in doing so, it allows the fishing boats to stay out for longer, reduces the catch burden, and these run boats are just going back and forth to the plant when they fill their holds up. Now, for our study, all of our sampling was conducted off of a run boat, which really was advantageous for lots of reasons, and I'll kind of talk about that in a second. Next slide. So they set the net around a target school of menhaden. The next thing that happens is the fishing boat or the run vessel pulls up alongside the net and it lowers this giant commercial suction hose into the net. That's how they basically transfer the catch from the water into the hold of the vessel, right? They're pumping it through this giant hose. Now, industry has used two what we call bycatch excluder devices for the last 30, 40 years or so. Basically, it's a mechanism at which they try to exclude or prevent non-target species, right? So your red drum and different bycatch from being sucked into the hose or ending up in the hold of the vessel that get brought back to shore. So the first of those is called a hose cage. It's this object here. As you would expect, the hose cage is on the end of the hose. It's basically a series of bars that prevent sharks, large drum, cow-nose rays, your big bycatch kind of constituents from being sucked up through that hose. So what happens is once they've finished pumping the catch out of the net, what you're left with is a net that's full of, in some cases, large bycatch individuals. And those are rolled out of the net. So they release them. The crew on the two purse boats just performs a rollover procedure and they roll them out of over the float line. And so that's the first of three bycatch areas. And remember I talked about these occurring simultaneously. So that's one of three. And every time I mention the rollover, that's what I'm referring to. Next slide. Now, this image on your right here is the same vessel I just showed you. Laying on the deck is that same hose, right? So once they've finished pumping, that hose is extracted from the net. Now, this is just a good way for me to kind of show you how catch is dealt with on the boats. So anything that's small enough to go through that hose cage gets sucked through the hose, it follows the direction of those green arrows, and it gets shunned through a fish pump up to this grate up here. This is called the excluder grate. Now that's the second bycatch excluder device that they use, right? So it's not just menhaden coming through that pump. There's some smaller individuals, bycatch that's mixed in. the industry uses this as a way to try to sort out some other bycatch. So the spacing of those excluded rate bars are wide enough that menhaden and your smaller bycatch fall through the bars. They go down this loading chute and they end up in the holds of the vessels. These are refrigerated holds that they use to maintain their catch before they take it back to shore. Now, bycatch that is wide enough that they're excluded by this grate instead gets sent down a different chute. Basically, this is called the release chute. So if you're wider than these bar spacings, instead you go down the direction of these yellow arrows. There's a release chute and you get released overboard. So the three bycatch areas, you got the rollover from before. You have what we call the retained, which is anything that's retained in the hold, and that's guaranteed mortality that goes back to shore. And then you have the chute bycatch, which is another component that is released by way of that release chute. Now, when I mentioned previous studies having difficulties kind of fully characterizing all the bycatch, the chute was really one of the main areas that there was issues with, because it was releasing bycatch overboard at a pretty fast rate, and it was very difficult for observers in previous studies to count, catch, measure, intercept that catch. So that's been one of the components that has had a bit of a data gap previously. Next slide. So to reiterate, right, we've got three components. We've got the rollover, we've got the chute, we've got the retained. There's a lot of things going on simultaneously. How do we go about it? We sent 4 to 6 fisheries observers out on these boats, and they were collecting and characterizing and weighing and measuring and counting all the bycatch that we could during these fishing operations. So it required a lot of manpower for us to really get a robust estimate and to fully capture everything that was going on. Next slide. And next slide again. So our objectives, I'll cover this kind of briefly, but our goal was, our overarching goal was to sample at least 2% of the sets. So a set in the context of this fishery is just setting the net around a school, pumping that catch out of the net, and then rolling it. So that's a set in its entirety. So our goal was to sample at least 2% of the sets across Louisiana fishery during the 2024 season. The season runs from April through October. Our objectives were to estimate bycatch, right, in terms of the number of bycatch and the total weight of bycatch, as well as the composition of bycatch. So what species of bycatch were there in the fishery and what quantities. In addition to that, it was to look at the lengths and the weight distributions, as well as the sex ratios. And then we had 2 separate objectives sort of related to the release bycatch, and that was to try to better understand, well, what condition are the fish that are being released in, and how many of them, for certain species, do we estimate are likely to survive. Next slide. Now, you don't want to just, when you're designing a study like this that covers the whole Louisiana coast and 7 different months, you don't want to just go out and sample in August from one area, right? You want to spread your samples both across the 7 months and also across the areas that the companies fish in. And so that was a key component of our study design. So we stratified our sampling so that we covered all of the 3 plants that operate. So it's Empire, Louisiana, Abbeville, Louisiana, and Moss Point, Mississippi. Those are boats that often fish in Louisiana waters. So we spread our sampling across those 3 plants, as well as across the 7 months. So during any given month, we would go to all 3 of those plants in a randomized order. And the outcome was that we had, observers on boats for 3 out of 4 weeks a month for 7 months during that 2024 season. Next slide. I talked about run boats, and I mentioned that they were advantageous for our study, and I'll kind of tell you why that was now. Basically, in the industry, they have a saying, and they say, fishing boats fish the fish, run boats fish the fleet. So what a run boat is doing is it's going from fishing boat to fishing boat, pumping from the nets. By putting our observers on a run boat, we were able to sample a lot of fishing boats within the fleet, right? If we put them on one fishing boat, They're stuck on that boat for the day. You don't get a lot of samples that cover the fleet as a whole. And so it allowed us greater access to sets to sample. It allowed us sets that were more independent of one another because we were able to capture more areas and more fishing boats. And they also had more space for our observers because they don't have purse boats on them, and so there's less crew. In addition to that, because they don't have the purse boats on the back, there was space for us to put these two large 1,200-gallon tanks so that we could maintain fish and record their survival. And I'll talk about that shortly. Yeah, next slide. And one more. So the next few slides, I'm just going to quickly cover, well, how did we collect bycatch? How did we estimate what was going on? What were our methods? So for the rollover bycatch, pictured here are two observers. At the end of the pumping operation, right, the crew rolls that catch out of the net. Our observers were there with long-handled landing nets, and they would intercept whatever they could. In this case, I think there's some black tips and some fine-tooth sharks being rolled out. They would then bring them on board, weigh them, measure them, count them. Now, because it's not an easy task, and in the speed of fishing operations, so fish would be missed on occasion. So to make sure we got a complete count of every bycatch in the nets, we deployed camera systems, filming at really high frames per second, so that we could go back, we could watch it, we could count all the bycatch. So we're getting lengths and weights on a subset of those individuals, and we're getting counts for everything. So it's a complete census of the rollover bycatch. Any questions? See a couple of puzzled faces. I just want to make sure. No?
What's that lower white photo?
This one? Yeah. So,
Lower right.
oh, this one? That's a GoPro camera that we use. And so that's one of the ways that we filmed what was going on.
Okay.
Yeah. Yep.
And how deep do these nets go?
So, off the top of my head, I can't remember what it is. I want to say 30 foot comes to mind. I forget the total depth of those nets, but the depth of the net depends on the depth of the water that they're fishing in. But it varies. Yeah. You're talking about the actual purse nets, right? Yeah. Next slide. So this is a shoot bycatch. Now, this is the area, right, that we mentioned that previously had been really difficult to get at. Well, we worked with industry, we brainstormed, and we had them divert that chute so that it came back on board the boat. So rather than missing everything as previous studies had, instead, anything that would have gone down that release chute instead ended up in our bucket here, in our 100-gallon tote, and then in the hands of an observer. So we were able to count and measure everything that came down that chute when our observers were on board. Yeah.
You have this excluder device at the end of your hose. Yet to get there, those fish have to go through that excluder device, right?
Correct. Yep.
That's a pretty big fish to go through an excluder device.
It is. Yeah. And on some boats, we saw sharks as big as 1.6 meters long go through that. And so, a large part of it is the angle at which they hit it. There's also the force of it being pushed down sometimes. So it really depended on, at what angle a fish hit it, I think. And the other thing I think I'll mention is that we'll get to this more towards the end, but the hose cages aren't identical across all the boats. And so on some boats, the spaces are larger, on some boats they're smaller. And so some boats had a higher tendency for bycatch to pass through than others. And this is a really neat outcome that we'll get to at the end. So, yeah. Next slide, please. So last of the three, this is the retained, right? And this is everything that ends up in the hold. We know these are mortalities, but we don't know what they are, what it constitutes. This was a difficult one, right? And this picture doesn't really do it justice, but when they're pumping 15,000 fish per minute. Okay, so you can't get a complete census on that, right? I've watched videos of it. It makes your eyes go funny when anyway, it's fast, right? So how do we go about it? What we use is this cage system, right? It's a big rectangular sampling cage that allowed us to pick a subsample. So during each pumping operation, we'd fill it with about 126 kilograms of catch. It was operated with this electrical winch. It's myself and Dr. Mudrak there operating it. And we'd swing that subsample around, spread it out on the table, separate the menhaden and bycatch, and that's how we were able to get at, well, what's going into the hold, okay? It's a subsample, and so Scott can talk about this in a little bit, but you're only capturing a small portion, and so when we estimate, you then have to expand it out to the total set, right? So if they put, 1,000 kilograms of catch in the hold during one set, and we only sampled 126 kilograms, you divide that and then multiply it out to get the total bycatch.
They know the size of the whole set because the captain times the pumping process. Turns out it's really accurate at determining how many menhaden you get from a given set based on this pumping time. That's how you know what the total catch is.
And the bycatch is fairly consistent through the entire pump, so your sample is.
Well, that's very good. Yeah, that's very astute.
It is. Did you listen to our original presentation? Well, that's great. I didn't include it, but I cut down this to keep it shorter, but I can talk about it because that's a great point. So that was something that we, spitballed when we were designing the study is what if, right, some individuals in the net are better swimmers, stronger swimmers, and they stay away from the hose cage for longer. And they only get sucked up towards the end, right? So if we only sampled at the beginning, then we might not capture that in our sampling. And so what we did is we split up our subsamples so that we either took one at the beginning, the middle, or the end. And we ran some analyses to look and see, was there a difference in bycatch across those three? And there wasn't. But better to find that out, having accounted for it, than to find that out after and realize that you'd missed a whole component of the bycatch. Next slide. I think this is where I get to step away for a second. It is perfect. I'll get a glass of water and wet my palate here, and I'll be back.
Say that
Yeah.
once they're in the net, they're gonna die, or when they come out to shoot.
No, so so anything that's released stands a chance to survive. And we'll talk about, we actually estimate that exactly, and we'll get
Floaters.
even better. Yeah.
That's still survive if they get sucked up and they go out there.
And they can, but it's a really low percentage. Oh, good idea. Sorry.
That's volume of fish. This is.
Mike, just clip it. Yeah, just clip it in.
Okay.
If you're running that much vacuum, moving those fish that fast, I admit that is probably the most humane way to move the amount of product that you have to a different area. But that has got to be tremendously hard on fish.
Oh, they don't.
Yes.
Yeah, well,
Yeah.
Lewis will show you that at the end. He'll present the survival results, and you'll see that if it goes into that hose cage, it's pretty much done for.
Yeah.
But they didn't wait. But before this study,
Birds flocking.
they didn't know for sure, and they even assumed that all the bycatch left in the rollover was mortalities as well, which is not what we found. But I'm getting ahead of myself. So my name is Scott Raborn, and Lewis said I live in Pineville. Lewis, it's Pineville, not Pineville. I know this because I'm from Rayville, Louisiana. If we have any Northeast Louisiana people in the room, but yeah. So I just work from home in Pineville, and I'm on the quantitative side. I'm a biostatistician, fisheries scientist. Mostly work with numbers. They don't let me go in the field very much. But my co-investigators, Dr. Louis Nesbitt-Jones and Dr. Pete Madrock, did an outstanding job of designing this study and just solving problems on the fly. I'd also like to give the industry a little bit of credit too in helping facilitate this study. They realized that they needed estimates, and they realized they needed good estimates. And so they helped problem solve, like designing the cage that we subsample the retained bycatch with, putting davits there, putting hydraulics, on it. And it just really facilitated things. So before we talk about the results, I want to talk about how representative our samples are of the fleet itself. And these two graphs on the right, the top graph just shows where every set was made by the fleet in 2024. And there were 13,144 sets made by the fleet. And the bottom graph shows the 418 sets that we sampled randomly. So spatially, it kind of gives you an idea of how representative we were. The size of the dots in the bottom graph is reflective of the size of the set, how many menhaden they caught. That's why you have different size circles. We were supposed to sample 2% of all the sets throughout the season. We were fortunate, and we got 3.2%, so we exceeded that goal. And there are only, how many boats are in the fleet, Lewis? 30, about 30, 32. We were able to sample every vessel at least 4 times. So we didn't have any boats that weren't sampled. If you break it up by plant, 3.4% of the sets were sampled out of Abbeville, 2.7% out of Empire, and 4% out of Moss Point. Next slide, please. So this sort of gets at the representative of our sampling. The x-axis represents how deep the set was, bottom depth of they were over, and on the y-axis it shows you how frequently they set in each of those depths. And the pink is for the whole fleet. And then the blue is for our sample sets. So sort of gives you an idea that we were sampling the same depths at the same rate as the fleet was setting. Next slide. Likewise, the size of the sets. On the x-axis, you have how many thousands of standard menhaden. Doesn't really matter what that means. It's just the higher the number, the larger the set. And then on the y-axis, you have the frequency of what's that happened. And the pink again is for the entire fleet, and the blue is from our 418 samples. So we sampled the fleet in proportion to the depth in which they set in and the sizes of the sets that they were making. Next slide. If you'll bear with me here, I'm going to get a little sciencey. When you have a survey, you can get an estimate from that survey in one of two ways. You can just take the average, and that would be what you call a design-based estimate, or you can build a statistical model that gives you a model-based estimate. And best analogy I can come up with is, let's say I wanted to know the average height of students in a school, right? If I randomly sampled 100 students from a school, any school in Rapides Parish, and it was truly random, every student had an equal probability of being in that sample size of 100, you're going to get an unbiased estimate of the average height of kids in that school. But if for whatever reason we didn't have, and every student had an equal chance of being in that 100, and it was maybe you chose, more girls than you did boys or whatever, you would have to have some way to account for that. And what you could do is you could build a statistical model based on the gender and the age of the child, and you could predict the height based on those two things. And if you knew the gender and the age of every kid in the school, you just predict the height of every kid in the school and get the average, and you get an unbiased estimate of the height. Even though your sampling was not necessarily random, you still get a representative unbiased estimate. That would be your model-based estimate. Ideally, you want to do both, which is what we did. We wanted to get as random a sample as we could, as representative a sample as we could. But in the event that that didn't happen, we wanted to get a model-based estimate as well. And if those two estimates are the same, then it means that you were probably successful in making your samples random and representative of the population, or you parameterize your model correctly and it gives you an unbiased estimate. And so we did it for the top 5 species, most numerous species from both the rollover and the shoot. We created a statistical model and we got an estimate from that. That's the darker gray bars. And then the design-based estimate, just the average, is the lighter gray bars. And they're a little different for a given species, but across all species, there's no consistent pattern there. And they're more or less, from a biological standpoint, they're identical. And design-based estimates are a lot easier to generate. And so that's what we did for all the other species as well. Any questions about that?
So those are some big species that got sucked into the chute.
Yeah.
So those holes are pretty big on that.
They're pretty big. So sometimes that chute will hit a big drum like this and hit it sideways and it'll get left into the rollover, right? But every now and then, sometimes it'll go straight head on and there's a lot of power in that pump and they'll suck them in. Now, I don't know if we show a link frequency histogram of the chute versus the rollover, but you see a slight, you have the link frequency distribution of the rollover fish and versus the chute. They're slightly larger in the rollover, but they overlap quite a bit. And a lot of it has to do with the hose cage design, and they weren't uniform across every boat. They're making strides in making that happen right now, but during 2024 season, that was what we encountered. So first, the rollover bycatch, 43 different species were encountered. 10% of the time we saw no bycatch in the rollover. The most numerous species were cow-nose ray, red drum, and black drum. On average, you had 2.04 red drum per set, 1.42 black drum, and then when you expand that out to the fleet, that comes to 26,752 red drum for the 2024 season that were left in the rollover, just that part of the bycatch, right? Next slide. The chute, top 3 species, gaff top, cow-nose ray, and red drum. And once you, 41 different species overall, 28% had no bycatch in the chute. And once you expand the red drum out from 1.36 average percent, you wind up with 17,841 in the chute bycatch. Next slide. And then in the retained, the most numerous 3 species were Atlantic croaker, sand sea trout, spot. We saw 62 different species. And as you would imagine, they're mostly the smaller individuals of a species or just smaller species in general. Red drum, largely absent.
Need more hard-headed catfish for that.
I know. Yeah. No doubt, no doubt.
How do you know all the full croaker is the
Well, yeah. So you see a lot of sand sea trout, and that expands to 24 million, and a lot of Atlantic croakers expands to 80 million. The speckled trout or spotted sea trout, it expands to 240,000. 368 individuals, but I think we only saw a total of 26 individuals in the subsampling. But we're sampling such a small portion of the total set. Once you expand it to the set and then you expand the set to the fleets, that 26 blows up to 24,000. Now, you'd say, well, how well is that subsampling doing? You only saw 26 speckled trout. Maybe you're missing a lot of them. Well, I don't see how, because we certainly weren't missing sand trout. right? If they're out, if we catch them in numbers, we're seeing them. And the way it works statistically, as long as you're getting a random sample, it doesn't matter how much the population is, how big the population is. If you're getting a random sample of that, you only really need statistically 403 individuals to get a good percentage estimate of the percentage that they represent. That may be a little too much statistics, but anyway, that's how it works out. Something I want to point out here. So if you add the shoot and the rollover bycatch for red drum, you wind up with an average of 2.8 red drum per set. And that's what we estimate. But you don't catch 2.8 red drum per set, just like you don't have 3.2 children, per household, right? So it goes like this: 0, 0, 0, 0, 0, 5, 0, 0, 20 on. And so I went ahead and created this frequency table. And on the far left column is how many times we saw 0 red drum in either the shoot or the rollover. And that was 226 times out of 418, or roughly 55% of the time. And then 46 times we saw 1 red drum in either one of those. And one time we saw 199 when you combine the shoot and the rollover. That's out of 418 sets. And I wanted to highlight this because throughout the study, we had various dignitaries, people involved with managing, setting the limits in the menhaden fishery. State agency personnel wanted to come observe the study. And so we had a contingency from Louisiana, and the former secretary that's now head of, what's her name? Madison.
Yeah.
Madison Sheehan.
Yeah. She went out and observed it, and all the higher ups in Louisiana Wildlife Fisheries went out and observed it. Chris Sheebley. I don't know if Patrick Banks went or not, but anyway, anybody that's involved with this fishery and with marine fisheries saw it. And they saw some relatively innocuous sets. The bycatch wasn't that high in the sets they observed. So they walked away with a certain view. I mean, well, we took the Mississippi group of Mississippi guys out, and they witnessed the worst day in terms of bycatch that we saw throughout the entire study. And they saw this set with 199. And one of the guys was, he doesn't work for Mississippi, but he works for the Gulf States Marine Fisheries Commission. His name's Steve Vanderkoy, and he was in charge of administering this funding, and he's the one who awarded us this contract. And he told me, he said, I saw that set, Scott, and I looked around at all the other menhaden boats, and you're looking at that set and all those drum, you're looking at all those other menhaden boats, and it can tend to paint a picture in your mind. But here's the problem with that. He just saw this one set, and he didn't see the 54% of the other sets that had 0 drum in it. So you have to be careful and not sample with your eyes. Humans are really bad about cherry picking their data. And if you're out there fishing and you happen upon this set with 199 and you're going to see some dead floating drum, it's going to stick out. What doesn't stick out is the 50 other sets that you went by and didn't see anything. So you have to make sure your sampling is random and you're not sampling by eye, all right? Is that all we wanted to say on this one? I think so, yeah.
So this is a 1-year sample?
Right.
Were y'all in the field for the entire season?
They were, like I said, they don't let me go, but I went on a few trips, but they were in the field 3 weeks out of every month from April to October.
Now, this was 2024, right?
Yes.
Okay, the new regulations came in 2024, which set the geographical boundaries.
Pushed them half a mile.
What is it, quarter? But yeah, that's when they, right.
Yeah.
2024 is when that came in effect.
Yeah.
Okay, so did y'all see any difference regarding that? I mean,
The depth?
yeah.
Yes, so I put depth, when I ran the model for the rollover and the shoot, I put the bottom depth that they set in as a variable, and it was significant. And do we have that slide at the end?
We can pull it up, yeah, it's on this presentation.
But yeah, okay, but if I can come back to that and we can talk about that. As you would expect, your estuarine species like gaff top, drum, what was the other one? Maybe black drum, red drum, black drum. The bycatch, you saw them higher inshore, but it sort of, once you got inside of 6 meters, it leveled off. It stayed there. And then once you got beyond 6 meters, it started to go down. Probably wasn't significantly different than bycatch in really shallow water until you got out to 10 meters, which is basically only maybe 10, 20% of the fishery occurs beyond that.
In some ways, it's unfortunate, right, that in an ideal world, you do a study before you implement a buffer, and you do it after, and you see, oh, what was the effect?
Yeah.
But we can't speak to what happened,
No.
within that quarter mile, because it was already imposed when we conducted the studies.
But you saw a pattern for the estuarine species, and then you saw a pattern for the opposite pattern for the more pelagic species, the jackerville, blacktip shark, cownose rays. They increased as you got in deeper water. Here, I think I'm just showing the as a percentage. This is a number that they always use in commercial fisheries. They want your bycatch to be a certain percentage below a certain percentage of the total landings. And for the rollover, you had, 145,000 individuals, roughly 140,000 in the shoot, 145 million for the retained. And then by weight, you convert that into weight, and then you divide that weight by the weight of the menhaden. And by number, you can convert it divided by the number of menhaden as well. By number, it was 4.57% of the landings. And then by weight, it was 3.62%. And by law, I think they have to be under 5%.
So the bulk of the fish will retain, bycatch.
Yes.
That's nature different.
Yeah, lots of.
It's just lots of small, yeah, right. And that's everything from shrimp to. What
do the fishery things do with the bycatch?
They grind them up with, it goes into everything else.
My dog food.
Yep.
Right.
Okay, this is where you come back in, Lewis.
All right. Still the whole thing up the shit.
Yeah.
You guys are heck savvy here. I like it. All right. So this is great because you guys already asked a bunch of questions about this. And so this is the survival portion, right? I'm not talking about the retained now. We know what happens to them. What happens to fish that are released, either by the chute or rolled out of the net? How do we get at that question? Well, we used two main methods, but the one I'll talk about first of all is we did a holding study. So we put these two large tanks on board the vessels, had a flow-through system that maintained water conditions that were consistent with the environment. And we would take red drum, black drum, and gaff topsail catfish. We picked those three species because they were abundant in the released bycatch, but also because of their relevance in the state. And we'd put them in these tanks, we'd monitor them for 24 hours, and we'd record what percentage of them lived, okay? What we did is that we put loggers in the tank so that we were constantly recording the dissolved oxygen levels, the salinity levels, and all the parameters in the tank so that we could assure ourselves that we didn't do anything that would have artificially killed the fish, right? So if our tank pump went out overnight and oxygen plummeted really low, we had a mechanism to look at that and go, okay, well, we messed up. And so we were able to account for that and produce an estimate that was robust and realistic of what was going on in the fishery. So next slide. So here is the silhouette of a red drum swimming around one of our tanks. We would tag the individuals with conventional tags so we could locate where they came from, either the rollover or the chute, but also individuals that lived that 24-hour period were released with these tags so that anglers fishing could recapture and report those instances too. Now, what we did is we measured and weighed these fish after the 24-hour period. So we tagged them really quickly. We put them in the tanks. We didn't want to handle them too much before we experimented because we didn't want to induce any additional stress or do anything that was going to bias the survival results in any one direction. Okay. Next slide. Now, the tanks were limited in space, right? And so we couldn't put every single red drum that we encountered in a tank. But we wanted to get at the condition of fish in general. So for individuals that didn't go in the tank, we would assess their condition. We'd look at the fish from the outside. We'd look to see if they had regular kind of gill movements. How vigorous were they? Did they have any external injuries? All these different metrics. And we would assign them either as a mortality, if we didn't think they would survive, or a poor condition, a good condition, or excellent condition. We did this for all the fish, okay? Now you guys, as fly fishermen that have worked on, caught many salmonids, everybody knows that, the longer you have a fish out of water, the more you handle it, especially in hot climates, the less likely it is to survive. And that was very similar to our outcome here, right? And, fish that came out of the net, got sucked through that pump, generally were in poor condition, right? You guys expected it, you guessed it, it's correct. So 2% of red drum were excellent, 2.9% of red black drum were excellent, 58% of red drum were mortalities initially that came through that fish pump, 42% of black drum. Now, gaff top catfish in the chute did a little bit better. They're smaller. I think they're able to go through that pump system without sustaining injuries as much. But that's a general pattern. Now, the rollover fish, your red drum, your black drum, and your gaff top that never left the net, stayed in the net, didn't have exposure to the air, didn't go through a pump, they did relatively well as far as condition scores go, right? 70% in excellent, 80% in excellent, or 45% for gaff top. Gaff top, it was a little lower because their dorsal spines, they'd get caught in the nets, and so they didn't fare quite as well in the rollover. Next slide. So that's just the condition scores, but we want to get a percentage on that in terms of what percentage of these fish actually survive. So this is the outcome from our survival study. These are the fish that went in our tanks. We tested 157 red drum, 88 black drum, 66 gaff top sail catfish across the season. Now, these are the survival results. So the take home is, again, similar to the condition scores. In the rollover, 83% of red drum survived, 87% of black drum survived, and 73% of gaff top sail catfish. Okay, so relatively high survival rates for rollover fish. By contrast, no surprise, it's consistent with the condition scores. 2% survival for red drum, 2% for black drum, 40% for gaff top. Next slide. So what we did then is we took our, the estimates that Scott showed you. So how many red drum did we encounter in the rollover? How many did we encounter in the chute? You apply that survival rate to them, and you get a number of fish that that we estimated were released alive, right? So for red drum in the released bycatch, so the rollover and the chute, there were 44,000 individuals, of which we estimated that close to 23,000 were released alive. For black drum, 25,000 estimated catch in the bycatch and 16,000 estimated released alive. And proportionally, it's higher for black drum because black drum were deeper bodied, and we tended to see more of them in the rollover than we did in the release chute. And obviously survival in the rollover was higher, right? So less black drum went through that pump. And then for the gaff top sail catfish, you have 63,000 estimated, 29,000 of which we estimate would be released alive. I will say, generally, as I haven't been on those boats a lot during the course of the season, drum from the rollover were really vigorous individuals when we pulled them out. This is the picture kind of showing. It was hard to catch them out of the net, out of those tank systems at the end. So they were really, active, healthy fish from the rollover. Now, obviously, that wasn't the case for the chute. Next slide. So this is the last slide of the presentation. Just, thinking about implications, next steps. Obviously, our our role was to produce these robust scientific estimates of bycatch. That's the first step, the key step, right, is that there's been all these data gaps, there's been this ambiguity. Managers needed something that they could stand by, some numbers that they could speak to. And what has that led to? Well, I think two things I'll point out. And the first one is that we talked about hose cages. We talked about variation in hose cages. One of the things that industry has adopted this season is they took of the three main designs they had, they took the hose cage with the smallest openings and they applied that to the whole fleet. So the first thing they've done is standardize their hose cages. Obviously, as a next step, this data is now available publicly. It's been handed to Fish and Wildlife and Fisheries, and there's their next step will be to kind of take these numbers and integrate them into stock assessments and try to work out, well, what are the implications to these findings? And so I think everybody in our group was really happy that we were able to provide robust estimates that covered the fishery without any data gaps. And we learned a lot from previous studies, and now, that information is out there and wildlife and fisheries can utilize it to manage the fisheries as they deem necessary. So I think that's it. Obviously, lots of people to thank. And as Scott mentioned, it's industry were very cooperative. They had us on board for 6 months. They accommodated any sort of modification that our scientists recommended so that we could generate the estimates that we were looking to. Questions?
Did you notice any difference in
Yes. Let me get a slide up. Do you want to step up and I'll try to find it? Is that okay? Thanks so much. Let's see here. I almost left this one in there because it's one that folks are interested in. There you go. Is that? No, that's not it.
If you have a link frequency of the shoot versus the rollover, that might be interesting to see too.
Yes. Okay, I'll start with this one because I found it.
Okay, so this slide is it's what the statistical package outputs and what I use in the report. But the y-axis is sort of frustrating. First of all, it's on a log scale, and it's the log of the change in the bycatch as a function of depth. So that's basically, the higher it is, the clearer the bycatch, the lower it is, the less the bycatch. And here's you're increasing in bottom depth on the x-axis. So for your pelagic species, black tip shark, cownose rays, crevalle jack, the trend is increasing like this. I mean, it's going up. These black dots is each sample. And that's what you call in statistics a partial residual. And the closer these dots are to that blue line, and the more that the black dots follow that pattern, the better bottom depth was at explaining the variation in bycatch of that particular species. If it didn't matter at all, then black dots wouldn't follow that line at all. They'd just be scattered randomly around, and it wouldn't matter. So for cownose ray, say for instance, depth did the worst job of helping to explain what the bycatch was doing. It was still statistically significant, biologically significant, probably not. But for jack crevalle jack, it was the best. For your estuarine species, bycatch increased once you got past a certain depth and shallower. And so for, say, red drum, it's more or less the same until you get out to about 6 meters. That's about 20 feet. And then it starts to drop off. And you may not see it, but this blue shading right here, 95% confidence band, it doesn't really deviate from 0 until you get on up to about 8 meters or so. And at that point, you're basically, I got to say, off the top of my head, 10 to 15% of fishery occurs beyond that depth. That helps answer your question.
So if they move beyond the half mile where they are now,
The half mile, yeah, so you don't know what the depth is, you know, the coast of Louisiana, I mean, it's right around Venice, it drops off really quick. And then if you get off of Con Island, you gotta go, you know, before you get in deeper water, you gotta go way offshore.
I noticed, I looked on log, Fisher's Grand Isle has a 3 mile buffer. So it means it's shallow. Is that probably one of the buffers?
I think for that one, they were worried about fish bills in the beaches, so they had a particularly.
That's about interacting with sport fishermen and
Yeah.
trying to minimize that. I mean, the fleet, it's a gentleman's agreement, it's not by law, but they generally don't fish on the weekends. Just because they don't want to interact with sport fishing. And so that pushes them off further off in certain areas is that reason. They didn't have some model to tell them what depth that you're trying to target.
And you'll know that, you know, there's not a scenario where it's low bycatch. All you're doing, depth just shifts the species that you interact with.
Yeah.
Right. Did you want to, I'll share that last one really quickly because.
Yeah, so basically for red drum, say for instance, if you wanted to use that as a way to minimize bycatch, you would eliminate, but before you could start having an effect, you would eliminate 75–80% of menhaden fishing.
Yeah, there you go.
I have a quick question. So how did this study compare to the previous studies and it sounds pretty robust how they did that with the prior studies that y'all did. And then how did the game division legislature react to it? Were they expecting it or
So
going on guard by it?
So the first question of no other study was able to capture all three components of the bycatch like we did. And we were able to do it because other studies either sampled at the plant or they sampled off of fishing vessels. No one thought to use run boats. And we have to give Daybrook or West Bank Fisheries, they own half of the fleet and Omega owns the other half. Because West Bank operates out of Empire and they're right there at the fishery, they really don't have run boats. They don't use them. But Omega uses them because their plants are in Moss Point and in Abbeville, and it takes a long time to go to Abbeville, you know, and so they need to keep their fishermen out there, so they use run boats. Well, West Bank Fisheries, when we went to sample out of Empire, they took one of their fishing boats out of, kept them from fishing, pulled the smaller boats off and turned it into run boat. And which facilitated us why we were able to do the study. So that's where we were able to sample all the different components. And it's a long way to answer your question, but like say for the rollover bycatch or the retained, how did our estimates compare to previous studies? Wasn't all that different as I recall.
It was similar, yeah. I mean, there's so many different ways you could draw comparisons, right? Given that there are 40 odd different species. I think maybe it's a good high level way to compare would be the total percent bycatch, right? I think ours was, what did it come out? It's got 3.2 or something like that percent of landings. Previous studies had estimates that range from 1.6 to 4%. So the outcome was similar. Now we saw differences in species.
Yeah. They didn't see as many black drums as we did.
Right. So we saw more black drum. We were able to, I think the one area that it differed a lot was the retained, because we got a more representative sample of what was going into the hole. So some previous studies, they used the tools that they had at the time, but they would just hold a little dip net under or something, and they weren't able to get large enough sample to paint a picture. So the retained differed a little bit in species composition because of that. But I think that the overall implication in terms of the amount of bycatch, it was relatively consistent.
If they were to get you, say, 2 years down the road to look at this again, could you just look at retain, since you now know, the relationship well enough between retain and the others to where you could look just at retain?
Well, if everything stayed the same, yes, but between now and then, they're gonna modify the host cages substantially. I imagine.
Yeah. The seasonal, seasonal shifts in species, distributions, things, there's a lot of variables, yeah.
Yeah, we talked about this possibility, for the rollover, we had a guy paying attention, counting the number of drum coming out. And if there was, say, 23 drum in the net, maybe we sampled 6 of them for links. But we weren't able to get the rest of them because they rolled them out. Because they're trying to get loose and make another set. And we don't need all of them. We just need a sampling to get a good representation of what the leak frequency is. But we had cameras set up, and we had another person that was, because sometimes people would get in the way of a camera that was in a fixed position, and you had a guy from the upper deck, and usually it was someone with an iPhone or whatever, but they were, that turned out to be the most important footage, I think. And so a couple of times we didn't really get good counts from the person on the boat, but the video saved us, and we were able to get every fish coming in. But you could theoretically put fixed cameras on it, and you maybe sometimes it would get cloudy, and so sometimes people get in front of it or whatever, but you don't have to get every set made by the fleet. You just have to get enough of them to go, monitor your roll as a bycatch. We put cameras on all the chutes going into the holes to try to get it the retained bycatch in a different way. We didn't go over any of that because it gets sort of, we're running long now, but anyway, it didn't pan out as well as we had hoped, but it did prove that we didn't bias it low, I guess. And so that was the first question you had. The second question, like I told Lewis, I think you need to be proud of this moment because it's the only time in your career where we made everybody happy. There's two narratives that have come out of this study. There are people who think that this fishery is the bane of all existence in the Gulf of Mexico, and there are people who think that it doesn't do anything. And both sides have used our results to prove their point.
Yeah, exactly. It's been
and Wildlife and Fisheries was happy because they have really good data now on which to assess which point is probably more valid, and they can put it in their stock assessments. So I'll stop short there. And
half dozen PRs and other things I've seen on this. Not one of them has questioned the study.
No, they all say it's a good study and did a good job, and that's where one of the best things. Man, most of y'all here remember Billy Graham, right? I grew up watching Billy Graham with my grandmother, and someone asked him a political question, and he said, "I don't answer political questions." And he said, "Why?" And he said, "My job is to teach people about Christianity, and if I answer a political question and a person happens to disagree with me on that particular issue, that lowers my ability to inform them about Christianity. It's not my job." And I always remembered that. I don't remember anything else he said, but I remember that. And so I guess what I would say is, before you ask, if we think that this fishery is a problem, I won't answer that. It wasn't our job. That's not what we got paid to do. We got paid to provide the estimates in as unbiased a way as we can. And if I happen to say something that you disagree with, and you can't go after my logic, then you're going to go after the facts. And I don't want anybody going after my facts. I'm not here to defend the menhaden fishery. I'm not here to defend the sport fishing industry or group. I'm here to defend our estimates. That's it.
They've done a similar study with shrimpers.
Judgment of the back.
Yeah. What about non-fishery bycatch?
So
So you get turtles and all that stuff messed up in there?
So, yeah,
How many times did y'all see these?
we had 3 turtles across the 415 sets.
Yeah.
They were all in a rollover, none of them went through the pump,
Yeah.
and they would look pretty healthy when they were released.
But we saw no dolphins. But the dolphins, they do encounter dolphins occasionally. When that happens, they try to, sometimes they can release it immediately or try to get, but sometimes they have to pump it out a certain amount before they can roll everything over because it's too heavy. So another thing that I've seen some reports, all these articles written. There was one article written that talked about it analogized to like taking a driving test. Like when you go to take a driving test, you're on your best behavior. And so they likened the study to that. They said, well, you know, the fleet was probably on their best behavior. This fleet had no way of controlling their behavior while we were there. I mean, when they had all the dignitaries on that boat and they saw that one set with 199 drunk, you would think they would have avoided letting us see that set, right? But they had no way of knowing what's in the bottom of that seine until they get there. They have no idea which sets are high bycatch and which ones are low. They just don't know. And when they would call us to come sample a set, we would start going to them before they even had the set closed. And so I just don't see how they could have controlled the results in that way.
It sounds to me like the fleet is really wanting a sustainable catch.
Yes, they want.
And they have figured. I know that I've talked to several old fishermen, and they like if you can't figure that part out, you need to farm.
Well, yeah. I mean, I graduated from Mississippi State with a doctorate in fisheries in 2000. I worked in fisheries in Newfoundland, in Alaska. I worked a lot with Bristol Bay sockeye. You wind up getting the smartest of the smart in terms of commercial fishermen involved, and they all show up at these meetings and they all want sustainability. LGL did the red snapper count for Louisiana. You may have heard of the great red snapper count that was done initially. They estimated 22 million, but that was because they didn't sample Louisiana. They were borrowing the estimate from Texas and applying it to Louisiana. Well, Louisiana is very different habitat, and that was not valid. We actually went out and sampled, and I did the estimation for all that, and I came up with 8 million. They didn't want to come up with 8 million. It didn't do me any favors, right? I like as a consultant, I like making people happy. And everybody had this 22 million stuck in their head because that's what been in the lease, but we had to, defend 8 million. And that went against, But what happened there was the fishermen the commercial fishermen that fish for a red snapper actually were advocating for it because they didn't feel like what they were catching was sustainable. We have seen a decline in red snapper population here this year. It's not the same fishery it was 5-6 years ago. So sometimes fishermen will advocate for more regulations, more limitations because they want sustainability.
And another thing, I went to several of those meetings in May. I can tell you, at one point, their backs were against the wall. I mean, they really were. And so they realized, and I can't remember the gentleman's name, Francois. Yeah, he was, he told me that he was very concerned. They want to be good partners. They want to be good citizens in the commercial fishery. And so I think for that reason, they were willing to do some things.
Yeah, like the shrimp industry, in the beginning, our mentor is a man named Benny Galloway, he's such retired, but he convinced the shrimping industry, you're gonna be better off if you let us collect good data and accurate data. You're gonna get closed less frequently. And sure enough, they were. So what was happening was they were going out if shrimper came in and asked him where he shrimp, and on his fish ticket he wrote Barataria Bay. He wrote that down in 1963. Well, for the next 40 years, that's what he wrote on his shrimp ticket because he didn't get any problems from it, right? That's not where he fished. So Benny convinced them to put a GPS tracking device on a subset of the vessels, and all of a sudden it completely changed where we thought the shrimping fishery was happening. And it was happening in a place that they weren't getting as much bycatch as they thought. So it lowered the bycatch estimate like that. It was because they were using good information. And so, kind of the same thing here. Francois is sort of a progressive thinker, and he wants to be regulated with good information because he knows that that's probably going to give him the best outcome. Not just for him, but for everyone. You know, there's something they could be doing. And, you know, it costs them 10% in catch, but reduces the bycatch by 99%, then, you know, makes sense.
I just got one quick question. How big is that hose?
How big is it?
Yeah,
That's the size of that big around.
The hose?
Yeah.
I'm trying to remember what the inner diameter of that thing is like about a foot, I think, but the rub is really thick around the side of it. Yeah,
Oh, I didn't know the diameter.
I think it's about that, right? Like
It's
14 inches or something, I think.
it's some serious pressure going on.
Yeah.
Any other questions? Scott, Lewis?
I thought we lost you there, but those are some great questions.
Yes.
I appreciate it.
Very you study.
you guys did a wonderful job.
We took a lot of technician level folks, so underground experience in the field, and a lot of them have gone on to do master's programs in fisheries or other observatory and things like that. We do from time to time. We'll do